Today's topic of presentation is acids and base. First, Arrhenius concept of acid and bases. Arrhenius, a Swedish chemist, was the first to define acids and bases in aqueous solution. According to Arrhenius, an acid is defined as a substance which contains hydrogen and which, when dissolved in water, gives hydrogen ions. According on minerals, acids like HCl, HNO3 and H2SO4 containing hydrogen when dissolved in water dissociate completely into hydrogen ions as HCl in water gives H positive and Cl negative ions. Arrhenius named these acids which dissociate completely in water as strong acid. They are another acids like acetic acid CH3COH, carbonic acid H2CO3 and phosphoric acid H3PO4 which when dissolved in water do not dissociate completely into ions. As a result, an equilibrium is set up between the ions and the undissociated ion molecule as shown below. CH3COH in water dissociates into H positive and CH3COO negative ions. Arrhenius named these acids are weak acids. According to Arrhenius, a base is a substance which contains hydroxyl group and which when dissolved in water gives hydroxyl ion OH negative ions. These substances like NaOH and KOH which when dissolved in water dissociate completely to give hydroxyl ions OH negative as NaOH in water dissociates into Na positive and OH negative ions. Arrhenius named these bases which dissociate completely in water as strong bases. There are substances which do not completely dissociates into hydroxide ions. Arrhenius named the substance as weak bases. For example, substances like NH4OH, MgOH2, AlOH3 do not dissociate completely to give OH negative ions and can be written as NH4OH in water dissociates into NH4 positive and OH negative ions. Hydrogen ions H positive obtained from the acids and hydroxyl acid OH negative obtained from the bases combined together to form unionized water. Arrhenius described the combination of H positive and OH negative ion as neutralization reaction. NaOH gives Na positive OH negative, HCl gives H positive and Cl negative ions. Combining right hand side of 7.1 and 7.2 we get Na positive plus OH negative plus H positive plus Cl negative gives Na positive plus Cl negative and H2O. Cancelling the common ions on both the sides of 7.3 we get H positive plus OH negative gives H2O. This is called neutralization. Arrhenius concept is very simple to apply and explain a number of phenomena like neutralization, hydrolysis of salt, strength of acids and bases. However, there are certain limitations which are described below. Arrhenius concept of acids and bases is applicable only in aqueous solution. This concept fails to explain the acid or base behavior of substance in non-aqueous medium such as liquid ammonia, liquid sulfur dioxide, alcohol, etc. Arrhenius concept fails to explain the acidic character of substance like CO2, SO2 and SO3 etc. and basic character of substance like ammonia, Na2CO3 and CaO etc. Arrhenius concept also fails to explain the reaction between an acid and a base in the absence of water. For example, ammonia and HCl in the absence of water gives NH4Cl. Although Arrhenius concept of acid and base suffer from a number of limitations, yet the concept is very useful and informative for an elementary approach. Second is Bronsted-Lowry concept. Arrhenius concept of acid and bases was further improved by Bronsted and Lowry. Both Bronsted, Danish chemist, and Lowry, an English chemist, in 1923 incidentally introduced the same definition for acid and bases. According to Bronsted-Lowry concept, an acid is a substance which can donate a proton H positive, whereas a base is a substance which can accept a proton. In other words, an acid is a proton donor, whereas a base is a proton acceptor. As a result, Lowry-Bronsted concept is sometimes called proton donor acceptor concept. This can be represented as acid 1 gives H positive plus base 1 means proton donor. Base 2 plus H positive gives in equilibrium acid 2 proton acceptor. According to Bronsted-Lowry, a neutralization reaction involves the release of the proton by an acid and the acceptance of that proton by a base. For example, the reaction between HCl and ammonia to form the salt ammonium chloride can be represented as ammonia and HCl gives ammonium and chloride ions. Bronsted-Lowry base and Bronsted-Lowry acid when react with each other gives NH4 positive and Cl negative. The curved arrow show how electron must rearrange to result in the transfer of hydrogen atom from the acid to a base. The unshared pair of electron on the nitrogen of ammonia is attracted by the partial positive charge on the hydrogen in the polar hydrogen chloride molecules. A comparison of the structure of the reactant and product shows that the hydrogen atom which was bonded to chlorine in the reactant is bonded to nitrogen in the product. Thus, a proton has been transferred from chlorine to nitrogen to act as a bronzed lorry base. A species must have at least one unshared pair of valence electrons so that it can form a covalent bond to the proton. To act as a bronzed lorry acid, a species must contain at least one hydrogen atom that is attached to an atom that is more electronegative than hydrogen. In this case, HCl loses a proton and is an acid. Ammonia accepts a proton from HCl and is a base. Some other example of acid-base reaction according to Lowry's Bronsted concept are acid HCl and base in H2O gives hydronium and chlorine ions. It is important to note in the above example that water acts as a base with respect to hydrochloric acid and sulfuric acid. Interestingly, water acts as an acid with respect to ammonia. Such a substance which acts as both an acid as well as base is called amphoteric or amphoteric substance.
Similarly, bicarbonate ion HCO3 negative behave as an acid and as a base. HCO3 negative plus NH3 dissociate into NH4 positive CO32 negative. Another example of amphoteric substance is hydrogen sulfate ion HSO4 negative. Conjugate acid base pair. Let us investigate a reaction between acid and base. H positive dissociate into HCl plus NH3 aqueous give NH4 positive plus Cl negative. HCl being an acid donate a photon and form Cl negative ion, whereas ammonia being a base accept a photon and form ammonium ion. Now the chloride ion has tendency to accept the photon, whereas the ammonia ion has tendency to donate a photon. In another word, an acid donate a photon and become a base, and a base become accept the photon and become an acid. Thus a base form an acid is regarded as conjugate base of an acid. Similarly, the acid formed from a base is called conjugate acid of the base. In the above example between HCl and HNO3, Cl negative is the conjugate base of HCl and NH4 positive is the conjugate acid of the base NH3. Acid and bases that are related by the loss or gain of hydrogen ion are called conjugate acid-base pair. The Cl negative and HCl, NH4 positive and NH3 are conjugate acid-base pair. We can represent the acid-base pair. Acid conjugate base plus H positive, base plus H positive conjugate acid. It is clearly indicate that any acid-base reaction which involve two acid or two base, these reactions are called conjugate pair. For example, acid 1 plus base 2 dissociate into acid 2 plus base 1. HCl plus H2O dissociate into H3O positive plus Cl negative conjugate base. Above reaction, HCl is an acid since it donates a photon, and Cl negative is conjugate base. Photon accept the photon, hence it is a base. Thus H3O positive ion is a conjugate acid. A strong acid has a weak conjugate base. Some example of acid base are as HNO3 plus H2O associate into H3O positive and NO3 negative, and so on. A careful inspection of the above discussion revealed that a substance is capable of showing acidic character only if the other substance is capable of accepting the photon, that is a base. For example, HCl is an acid in aqueous medium because water can accept the photon from HCl. However, HCl is not a base in benzene because benzene does not accept H positive ion from HCl. Not only neutral molecule but cation and anion may act as acid or base. Both Arrhenius or Bromley-Rowley concept require an acid to be a source of photon. Thus, all Arrhenius acids are Bromley-Rowley acid. According to Arrhenius, a base is a substance which gives OH negative ion in the solution. NaOH in the presence of water they associate into Na positive and OH negative. Whereas according to Bronsted-Lowry, a base is a substance which can accept a photon. CO3 2 negative plus H positive become bicarbonate ion HCO3 negative. Carbonate ion cannot give OH ion in aqueous solution, so therefore it cannot be Arrhenius base. And thus all Bronsted-Lowry bases are not Arrhenius bases. Limitation of Bronsted-Lowry concept. Although Bronsted-Lowry concept could not explain the shortcoming of Arrhenius concept, yet it could not answer some well-established reaction. It cannot explain the reaction between acidic oxide like CO2, SO2, SO3 with the basic oxide like CaO, BaO, MgO, which take place even in the absence of water. CaO plus SO3 give CaSO4. Clearly, the reaction between CaO and SO3, there is no photon transfer involved in the reaction. The acidic nature of compound like BF3, FeCl3 and AlCl3. Lowry concept of acid and base. G. N. Lewis in 1923 proposed a more general definition of acid and base, which is depend upon the donation and acceptance of electron pair. According to Lewis concept, an acid is a substance which can accept a pair of electron. A base is a substance which can donate a pair of electron. Acid is a substance which can accept a pair of electron. Base is a substance which can donate a electron. Another word, an electron is an electron pair acceptor. Acid is an electron pair acceptor. It means a substance which has vacant orbital to accommodate one or more pair of electron can act as Lewis acid. On the other hand, a base is an electron pair donor. It means that any substance that unshared pair of electron can behave as Lewis base. Thus, the acid-base or neutralization reaction involves the formation of coordinate bond between the electron pair donor and the electron pair acceptor. For example, the reaction between boron trifluoride BF3 and ammonia NH3 is a typical Lewis-base acid reaction. Let us discuss in detail Lewis acid. According to this concept, Lewis acid are classified as molecule having central atom with incomplete octet of electron. BF3, boron trioxide, ammonium trioxide are acid of this type. Simple cation. All the cation are of short electron can behave as Lewis acid. Large sided cation like Na positive, K positive, Ca2 positive, Ba2 positive, etc. behave as Lewis acid. This is because they have little tendency to accept electron. On the other hand, small size cations such as H positive, Ag positive, molecule in which the central atom has vacant d orbital may acquire more than 8 electrons. Example AlCl3, SiF4, SnCl4. Fourth, molecule with a multiple bond between atoms of dissimilar electronegativity. A carbon dioxide represents an interesting example of double bond between carbon and more electronegative oxygen atom. Oxygen, being more electronegative, has tendency to attract the shared pair of electrons moved toward it in CO2. As a result, it required positive charge on the carbon atom and became electron deficient and attached with the oxygen to the hydroxide ion. Similarly, sulfur trioxide acts as a Lewis acid toward water. Lewis base. According to this concept, Lowry bases may be defined as one of the following type of substance: negatively charged anionic species. All the electronegatively charged species are Lewis base because they are rich of electron and have a strong tendency to donate electron pair. Common examples: Cl negative, O2 negative, OH negative, NH42 negative. The greater the charge density on the anion, the stronger is the base. Second, neutral molecule with one or more than one shared pair of electron. Molecule with unshared pair of electron act as Lewis base. Alkene and alkyne with multiple bond also form coordinate bond with matter in the organometallic compound. Acid-base reaction according to Lewis concept. Some typical acid-base relationship involving the formation of coordinate bond between Lewis acid and Lewis base. Combination reaction between H positive and NH3 Lewis base, H positive Lewis acid form ammonia ion. Combination of BF3 and F negative ion form tetrafluoroborate ion. Combination of calcium oxide and sulfur trioxide. Lewis acid and base combine and form calcium sulfate. It is important to note that an empty orbital is being created on the sulfur atom by moving a pair of electrons from double bond on the oxygen atom. Combination of cupric ion with ammonia. Cu2 positive Lewis acid plus 4NH3 Lewis base form tetraamine cupric ion. Combination of stannic chloride with ether to give an adduct. Lewis acid when react with Lewis base is given adduct. Lewis acid base concept discussed above is widely used before of its simplicity in understanding many acid-base reactions. In spite of its wider application than Arrhenius and Bronsted-Lowry concept, it has several disadvantages which are now discussed below. Lewis acid is too general and considered all reaction for the formation a coordinate bond to be acid-base reaction. This is however not true always. According to Lewis concept, some of the transition matter that form compound with carbon monoxide such as NiCO4, FeSCO5, etc. are acid-base reaction, which is not correct. Formation of coordination bond between an acid base is the basis of Lowry concept. However, the well-known acid like HCl, HNO3, H2SO4 do not form any coordinate bond with the bases like NaOH, KOH. According to LCl, HCl, HNO3, H2SO4 should not be regarded as acid according to Lewis concept. Lewis concept does not give only uniform scale of acid and base strength. Lux food concept of acid and base. A new concept of acid and base was proposed by Lux in 1930, and this concept was further extended by Flood in 1947. According to Lux Flood concept, an acid is any substance which accepts an oxide ion, whereas a base is a substance which gives up oxide ion. Lux food bases can be represented base dissociate into acid plus O2 negative. Example CaO dissociate into Ca2 positive plus O2 negative. And Lux flood acid can be tentatively represented as acid give C base minus O2 negative. For example, SiO2 dissociate into Si4 positive plus 2O2 negative. Thus, Lux plus acid base reaction can be represented as acid plus base form salt. SiO2 plus CaO forms CaSiO3. CO2 BaO form BaCO3. SO3 plus BPO form PbSO4. P2O5 plus 3Na2O form 2Na3PO4. According to Lux flux concept, substances that show a tendency to lose as well as gain an oxide ion are termed as amphoteric. Zinc oxide represented an interesting example of amphoteric character. For example, zinc oxide can lose O2 negative to form Zn2 positive ion in addition of zinc oxide gaining an O2 negative to form ZnO2 2 negative zincate ion. ZnO dissociate into Zn2 positive plus O2 negative basic. ZnO plus HS2O7 2 negative give Zn2 positive plus 2SO4 2 negative. ZnO plus O2 negative gives ZnO2 2 negative acidic. ZnO plus Na2O give Na2ZnO2. Similarly, Al2O3 can behave as acid as well as base in Lux flux sense and hence act as amphoteric. Al2O3 gives 2Al3 positive plus 3O2 negative basic. Al2O3 plus O2 negative give 2AlO2 negative acid. This concept of Lux flux is usually at high temperatures, especially in gases, ceramic industry and Metallurgical operation. The concept of lux flux can also be extended to halide and sulfide in place of oxygen. For example, acid plus base gives salt. AlF3 plus 3NaF gives Na3AlF6. CS2 plus Na2S give Na2CS3. You sandwich concept of acid and base. You sandwich concept of acid and base is very generally and take into consideration all the concept of acid and bases proposed by Arrhenius, Lowry, Lewis. In addition, this concept include all oxidizing agent as acid and all reducing agent as base. According to this, acid is a substance react with base, give up cation, accept anion. In this concept, base is defined as substance that react with acid and give up an ion or combine with the cation. Some of the examples are acid plus base gives salt, SO3 plus NO2O give Na2SO4, Na2O yield O2 negative ion, SO3 combined with O2 negative. FeCN2 plus 4Cn give KF Sb2S5 plus 3NH3 twice S give 2NH4 twice SbS4. Cl2 plus 2K give 2KCl. K loses on electron or K is a reducing agent. Cl gain an electron. Cu is an oxidizing agent.